All right, here are the answers to homework number 10. All right, let me go over them. Number one, I'm supposed to write an equation in slope-intercept form. Parallel and passes through. Okay, so parallel to this line means my slope needs to be -4 because lines that are parallel have the same slope. And my line passes through this point. So my equation would be y plus 1 equals -4 times x minus 3. That would be using the slope and the point 3, -1 and point slope form. Now I'm supposed to put it in slope-intercept form. So to put it in slope-intercept form, I would distribute the -4 and get plus 12, right? And then I would subtract 1 from both sides. And my final result would be y equals -4x plus 11. Perpendicular to this line, perpendicular means my slope needs to be the opposite reciprocal of this slope. Well, this line has a slope of 1, so the reciprocal of that is also 1, but I want the opposite reciprocal, so it'd be -1. My slope is -1. And then I can use my slope and my point, and I can write my equation. Y plus 3 equals -1 times x minus 2. I now need to put that into slope-intercept form. So I'm going to distribute the -1, get y plus 3 equals -1x plus 2, and then subtract 3 from both sides, and end up with y equals -1x minus 1. Or you could just write y equals -x minus 1. All right, problems 3, 4, and 5. I'm supposed to tell if these are opposite reciprocals. So flip them over, change the sign. -2/1, you flip it over, it'd be 1/2, change it to positive. Yes, they are. But these two numbers, number 4, they are reciprocals, but they're not opposite reciprocals because they're the same sign. So no, not opposite reciprocals. And these are opposites, but they're not reciprocals. So no, those aren't opposite reciprocals either. Number 6, I want equations of parallel lines. Well, that gives me a lot of freedom to do whatever I want, really. All I have to make sure is that I have the slopes be equal. So maybe I'd have one of them be y equals 2x plus 5, and one of them be y equals 2x plus 11. Pretty much as long as you make the slopes equal, the lines will be parallel. All right, here I have to find all pairs of parallel lines and perpendicular lines. I think the best thing to do here would be to first find all the slopes. So, this guy is already in slope-intercept form. He has a slope of 3. This guy is a horizontal line because he only has a y, and horizontal lines have a slope of 0. This guy is a vertical line because he has only an x in the equation, so his slope is undefined. This guy is in point slope form, so his slope is right here, -2. This guy is also in point slope form, so his slope is right here, 1/2. And this last guy is in standard form. If I subtract 9x from both sides, and divide by -3, I would find out that his slope is -9 divided by -3, which is +3. All right. So let me look for parallel lines first. That would be lines that have the same slope. This guy and this guy have the same slope, so lines A and F are going to be parallel to each other. Anything else equal? I don't think so. Let me find perpendicular lines. Well, this guy and this guy are opposite reciprocals, so lines C and E are perpendicular because they are opposite reciprocals. Also, this guy and this guy, that's a horizontal and a vertical line, and they are perpendicular, so that would be B and D. And I think that is all my pairs of lines. 8 through 10. All right. Number 8, okay, so I'm supposed to answer always, sometimes, or never. A horizontal line is parallel to the x-axis. Well, that's true. This is the x-axis, and this is a horizontal line, and they are parallel almost all the time. You might be surprised that the answer is sometimes, and it's sometimes because a line is not parallel to itself. The x-axis is a horizontal line, and that would not be parallel to itself, so that's the only horizontal line that's not parallel to the x-axis, and we would say sometimes. That is up for argument, by the way. Some geometry books might tell you that a line is parallel to itself. Number 2, two lines with positive slopes are parallel. No, you could have a line with a slope of 2 and a line with a slope of 3, and they would not be parallel, even though they both have positive slopes. But you could also have two lines with a slope of 2, so I guess that would also be sometimes. If they're the same positive number, they are parallel, and if they're not, they're not. All right, last up, number 10, two lines with the same slope and different y-intercepts are perpendicular. Now, two lines with the same slope are parallel, not perpendicular, so that would be never. To be perpendicular, you need to have opposite reciprocals for your slope. Number 11, will the graph of the line represented by the table intersect the graph of the equation? Well, as long as they're not parallel, they will intersect, right? Only parallel lines do not intersect in a plane. So let's see if they're parallel. This guy has a slope of 4. Over here, up by 4, it's linear, and the slope of this would be y minus y over x minus x. That would be 4 over 1. That would also be 4. All right, so the slope of both of these is 4. Will the graph of the line represented by the table intersect? No, they are parallel. And parallel lines do not intersect. Number 12. This is a tricky one. I am given two equations, and I want to know what value of k would make the lines parallel. So what value of k would make them have the same slope? Let's put them both in slope-intercept form first to see what their slopes are. This equation, it would be in slope-intercept form if I divided everything by 12. So it has a slope of -1/4. This equation, I would be dividing everything by 6, and I would get y equals k over 6x minus 5/6. So, what value of k makes this slope and this slope equal to each other? I need to solve that equation. K over 6 equals negative 1/4. I need to solve what value of k makes k over 6 equal negative 1/4. Then they'd have the same slope and they'd be parallel. Well, one way to solve that would be to recognize it's a proportion. It's a fraction equal to a fraction. And I can solve it by doing the cross products, right? So this would be k times 4 equals 6 times negative 1. Or if I divide by 4, I get k equals negative 1.5. So if k equaled negative 1.5, those lines would be parallel. All right. Next up would be part B, what value of k would make the graph perpendicular? So for these two lines to be perpendicular, their slopes need to be opposite reciprocals. Well, the slope of the first line is negative 1/4. So the slope of the second line would have to be positive 4 over 1 to be perpendicular. So now I'm really saying k over 6 would have to equal 4 over 1 if it's going to be perpendicular to the first line that has a slope of negative 1/4. All right, again, I have a proportion here, a fraction equal to a fraction. I can take the cross products to solve for k. K times 1 equals 24. Look at that, it's solved. K would equal 24. And if k equaled 24, those lines would be perpendicular. That's a hard one. Number 13. This is another kind of time-consuming one, sorry. I've got this triangle somewhere on a coordinate plane. And the point P is at 4, 3. And the point Q is at 2, negative 1. And the point R is at 0, 1. So the question here is this triangle a right triangle? If it's a right triangle, it means somewhere there's a right angle. Or it means two sides must be perpendicular to each other for this to be a right triangle. So I need to check the slopes of the sides to see if any of them are perpendicular. So I might start with side PQ. And the slope of side PQ would be y minus y over x minus x. That would be 4 over 2, or 2. All right. Now let's go to side RQ. Okay, so I've done this side. Now let's go to this side, RQ, and do the slope of RQ. And that would be the y value minus the y value, 1 minus negative 1, over the x value minus the x value. That'd be 2 over negative 2, which is negative 1. And last up, let's find the slope of this line, if it were on a coordinate plane. So again, I'm going to do, let's see, the slope of RP. And that would equal y minus y, that'd be 3 minus 1, over 4 minus 0. That is 2 over 4, or 1/2. All right. So look at my three slopes. Are any of them opposite reciprocals? I do notice that the red one and the green one are reciprocals, but they're not opposite reciprocals. So none of these three lines are perpendicular to each other, which means none of them form a right angle. So this is not a right triangle. Not a right triangle. All right. Number 14 wants me to name the x and y intercepts. To name the x and y intercepts, I'm going to need an equation for the line. So I'm going to need to take these 2 points and figure out the slope and the y-intercept, or use point-slope form and write an equation for the line. The first thing I'm going to do is figure out the slope by doing y minus y over x minus x. That gives me negative 3 over negative 9, which unfortunately is positive 1/3. All right. So the equation for this line in point-slope form would be y plus 5 equals 1/3 times x plus 5. All right. Maybe I simplify that. I don't know. Yeah, let's distribute the 1/3. That'd be 1/3 x plus 5/3. I'm not sure that's any better. You know, if I was good at mental math, I might multiply everything by 3 to cancel out the fraction. 3y plus 15 equals x plus 5. And that is the equation maybe I use to find the x and y intercepts. Nah, I don't know, maybe. The bottom line is to find the x and y intercepts, I need to put 0 in for the opposite variable. So, if I put 0 in to find the x-intercept, if I put 0 in for y, I would have 15 equals x plus 5, or x equals 10. To find the y-intercept, I would put 0 in for x. That'd be 3y plus 15 equals 5. And maybe I subtract 15 from both sides and get 3y equals negative 10. And then I divide by 3 and I get negative 10/3. So my x-intercept is 10 and my y-intercept is negative 10/3. Last up, suppose your child is having your school is having a talent show to raise money. You think that 200 students and 150 adults will attend. It will cost $200 to put on the talent show. What is an equation that describes the ticket prices you can set for students and adults to raise $1,000? You know, now that I read this, I got this wrong when I gave you the answers at the beginning. I want to describe the ticket prices. So I need my variables to represent the ticket prices. X might be the cost of a student ticket, and Y might be the cost of an adult ticket. And now I think I'm ready to write my equation. The equation is going to look like this. Dollars for students plus dollars for adults is going to equal total dollars minus costs. All right? That is how much money I'm going to make. Now that might be a little confusing for you, but how much money am I getting for students? It says here that 200 students are going to come. And if the cost of student tickets is X dollars, then 200 students times X dollars would be how much I would make off student ticket sales. All right? 200 tickets times the cost for each one. Plus, Same idea here. 150 adults are coming, and they're each paying Y dollars. So 150 times Y would be the total amount of money I make off of the adult tickets. And that is going to equal the total dollars I make, which is $1,000, but I have $200 in costs. So if I want to make $1,000, I'm actually going to have to add that on to the money I want to make so that I can then spend it. And this would be $1,200. The $1,000 I want to make plus the $200 I need for costs so that I make $1,000, right? And that would be my equation. All right.